Might change the only thing that just to see
That's fine.
Hey. Hey everybody. So today we have a bunch of things to do. We're going to cover the last topic of the term, which is going to be the iterator abstraction, right? So we'll do that, and then I'll talk, actually to start with, I'll talk about the demo and kind of everything you need to know about the demo, and you get to ask me questions about how you're going to demo the project. And then in the very end, we're actually going to fill out TA evaluation forms. So our TAs, we have a lot of them for this class, and they're all awesome, and you should, give them good feedback so that they can improve their work. And a couple of announcements. One is that, just as a reminder, the project is due on Monday. Still due on Monday. Just like yesterday, just like tomorrow. Due on Monday at 11:59 p.m. You make sure to commit your code to the master repository. Okay? And then secondly, the second announcement is that there'll be no computers on the final. Unfortunately, we think we're still in the gym. It seems to be unclear. So our request for a room with computers was not replied to, really. So we're going to go ahead and say that the final is not going to have computers on it. Okay? So prepare accordingly. So before we get into the iterator pattern, I wanted to talk a little bit about the demos and what we expect of you on the demos. So here's a marking scheme for phase 2 of the project. This gives you kind of the breakdown of the relative weight of the individual parts of the project that you're working on. Now remember, the project is 2/3 of your grade, so you need to do the project in order to pass this course. So this relative weight is, of course, you should think, needs to be reflected in your demo, right? So if the plot route calculation is 20%, right, then if you want to get all of those 20%, you have to demonstrate to us that you've really done that properly, right? So this is one aspect that will guide your demo. The second aspect to the demo is that at the top of the phase 2 page, you'll see that there's actually a list of expected deliverables. Long list of all the things that we want your Waldo app to do. So what that means is that, in the demo, we expect you to cover all of these, right? So if we don't see it, we're going to ask you to cover it. So just spare us, that question, and just go ahead and plan your demo so that you hit each of these bullet points, right? So by the time we get to your emulator's running, you have 10 minutes, and you can tell us, well, I need, the first thing I need to do is I'm going to, make sure that my user shows up on UBC campus. If I give them the following coordinates, here's my little yellow guy. The yellow guy comes up. Then next, if I request Waldos, then here are the Waldos. They get plotted. If I select the Waldo, here's what shows up. Right? So kind of break it down step by step. Make sure to practice it as well, because you sort of want a script, which is why this last task 9, is to prepare the demo. Most of that really just involves, going down this list, making sure that you know exactly what you're going to do for each of the bullet points. You have 10 minutes for the demo. So by the time we get to you, in lab or in lecture, make sure that you're completely prepared. Right? So Waldo is fired up. Everything's working. You have internet so that you can access all the necessary services. You have the demo in front of you. You know who's going to be talking. For the demo, you can designate one person to give the demo. So we don't expect, two of you to be kind of tag teaming or involved in it. So if you find it easier for one person to do the demo, just say, okay, Joe's going to demo, the app. That's completely fine. The one kind of individual component part of the demo is the question and answer. So after you demo to us all of the functionality in your app, we're going to ask both of the teammates individually some questions, like 2 or 3. And essentially, those questions will determine, that kind of individual component of the grade. So the bulk of your grade has to do with the functionality within your app. And that's going to be what the demo will demonstrate to us. And then the individual QA will tell us, how much, the person actually knows the code. So for that question and answer period, you both have to know the code that you've written. We don't expect you to know the code that we gave to you. So we're not going to ask any questions about that code. But any code you've added to the project, you need to know the code you've added and the code that your partner added. Right? So saying that I didn't write this code is not a good excuse. And then finally, the one note about answering questions about the code. So, here's, here's some code, random code from SI Game and Space Invaders Refactored. So, you'll get a question that's in the format of, show me the code that handles key presses in SI Game and explain it to me. Okay, so that would be like a valid question that you may get in the demo. And so what you need to do is you need to navigate to this code and you need to explain it to us. And by explaining it to us, we don't mean that you kind of say, well, at line 49, right, we have this if statement, and it compares the get key code return value against key event.vk.kp_left, or, so we don't expect you to read it, right? We can read that. I think what we want is for you to tell us what it does and why it does it this way. All right, so you tell us, so a better way of describing this would be to say, so every time a user presses a key, this function executes, and the details of the key are passed as an argument. And so what this function does is it's going to compare that argument against the key presses we care about. Things we care about are, pressing a key to the left, to the right, spacebar, R, and the key X. And for each of these, we're going to execute different actions. Right? For left and right, we're going to make the tank go different ways. We're going to fire a missile in space, and so forth. So that's kind of a more high-level description of this function, right? Which will actually convey more understanding, right? More comprehensible. So that's what we want you to do in that QA period. Any questions about the demo and what we expect you to do? No?
Do we need to do it in one computer, or?
You want to use 2 computers for the demo? Yeah, I mean, 1 computer is sufficient. Right? So if you feel like you need a second computer in case the first one doesn't work, that's completely fine. Have a computer as a backup. Absolutely. So bring whatever equipment and props you need. So if you need to wear a hat to give the demo, wear a hat. Make sure to hydrate. Eat your breakfast. All the good things. Okay. Any other questions? Great. So the key to demos is preparation. All right. So you want to get together with your partner, and you want to say, okay, the next 10 minutes we're going to practice the demo. Right? And you're going to have a script, and you have to go down the script, and don't stop. Okay? That's the only way to really do it. The only way to be prepared for the demo. Okay, so each of you should do that. Okay, so let's talk about iteration abstraction. So over the course of the term, we talked about different kinds of abstraction. Right, so we covered 2 types of abstraction already. The first of which is procedural abstraction. Second of which is data abstraction. So we spent a long time on data abstraction. Right, and this is where we talked about interfaces. This is where we talked about how interfaces hide implementation details, all of these things. So the third kind of abstraction we'll cover is iteration abstraction. And iteration abstraction is going to be covered in terms of the iterator design pattern. And we're going to focus on this iterator design pattern in the context of Java, as usual. And you've actually already seen this pattern. So really, when we talk about the iterator design pattern, this is what drives all of the for each loops that you've observed. So as an example, let me bring up Space Invaders Refactored and show you a bit of code that you have already seen and you already know how it works. So here it is. So let's say we want to look at this function for moving the sprites. So moving the sprites really just iterates through some collection of sprites. So the sprites is a field, it's a list that contains sprite objects. And what this loop does is it's a for each loop and says that for each sprite within the sprites collection, we're going to call it next, and then we're going to invoke next.move on it. Okay? So this is a use case that for the iterator. So you already know about it. Now, what you don't know about it is that underneath, there's actually a bunch of details. So when you use a for each loop, really what you have is something that looks like for type variable, colon, and then I have some collection. And so for every item in this collection, I want to do something with this variable. So if it's a sprite, I might want to move it. If it's an invader, I want it to invade. If it's a missile, I want it to move up. Whatever. So this is kind of a pattern for a for each loop within Java. Now in practice, this code is actually kind of sugaring for another piece of code that's much more complicated. A piece of code that actually uses iterators kind of in the raw. Right? And so if I have a piece of code that's iterating over sprites, which might look like for sprite, a sprite, sprites, a sprite.move. So this is an instantiation of this for each pattern, right? So this code is actually internally what that code is equivalent to is a version that uses iterators. The version that uses iterators looks like this. I'm going to first create an iterator object that will iterate over sprites. So I'll create a variable iterator. And I'm going to extract this iterator from the collection. So I have my collection here is sprites. So I'm going to say sprites.iterator. Now that I have this iterator, I can call certain methods on this iterator. And a traditional way to convert this for each loop is into a while loop, where I'm going to query the iterator. And I'm going to say iterator.hasNext. And if I have one more element in my collection, hasNext will return true, which will then lead me to execute the body of the loop. And in the body of the loop, I actually need to get an instance of sprite, because I actually need to move my sprite. So I'll have something like sprite a sprite equals iterator dot next. And now that I have the sprite, I can call move on it. So I can say a sprite dot move. So the piece of code here and the piece of code here, they're actually equivalent. They express exactly identical functionality, right? And in fact, internally, what the Java compiler does is that for every for each loop that you have that looks like this, it converts it into code that looks like this. So in a sense, this is just a shortened version of this code. So let's try to understand exactly what goes on bottom here. So this code is pretty simple to understand, right? So I have a collection of sprites, and this is just a way of iterating through the sprites. But what in the world is going on here? So one way to think about iterators is with the following diagram. You can think about this code as, having a collection, and this collection is exactly the sprites list. So I would have some set of sprites, sprite 0, sprite 1, sprite 2, sprite 3, sprite 4. And I want to move through this list. So I'll have an iterator, and my iterator is going to remember my position within this list. So initially, my iterator is going to point to the first element as 0. And so if I call hasNext, it's going to say, yeah, sure, I have an element that I can give you. And when I actually call next, it's going to return as 0. Every time I call next, this pointer actually moves. So the next time that I use the iterator, it's actually pointing to S1. So it iterates through the collection. So when I call hasNext and I'm at S1, it says, sure, I have an element for you. So I still execute the body of the loop. So now next returns S1. And after calling next, my iterator points to S2. And so the iterator goes through this list in a way, in some sequence, according to the internal structure of that data structure. So iterating a list, we'll typically iterate it in order, right, from the 0th element to the n-1st element. If you're iterating a set, which has no order, then you're just retrieving elements in some random order. So this is what the iterator does underneath. Yeah?
Is there any scientific version of the iterator?
So the question is there any advantage to writing this code as opposed to this one? There is. So if you had two iterators, like let's say you wanted to actually iterate this through sprites, with a second iterator, where you wanted to, for example, compare two adjacent sprites. You wanted to check if, sprite at position I is equal to position sprite at I minus 1. Then you want two iterators that actually move in synchrony across the list, right? So this for each loop will not allow you to do that. The for each loop is basically a way of using a single iterator. So if you wanted two iterators, you would actually need to write this kind of code. So it's definitely useful in cases where you have logic that's slightly more complicated than just blindly iterating through a collection. Okay, so for now, it just seems like a bunch of code that I'm writing. But there's actually a design pattern hidden in here. And the great thing about design patterns is that you can apply them to your own code. So instead of just having this iterator abstraction that you can use on Java collections, Java lists, and sets, you can also build an iterator of your very own. If you know the interfaces, if you know what to implement, what to extend, and so forth. Right? And that's the great thing about design patterns. So in order to actually figure out how to use this code, how to apply it to your own code, you have to understand what these interfaces are. And so in Java, if you consider the Java list API, for example. So my list documentation will tell me that a list is an interface. And it's an interface that has a super interface, collection. But it has two super interfaces. It also extends iterable. So iterable is exactly the class that you need in order to give your class this iterator abstraction capability. Right? So list extends iterable, which is why when we have an object of type list, we can say for element list. Right? This is why we can iterate through lists. So if we want to iterate through objects that we define ourselves, types that we define in our own projects, then we would need to extend this interface. And what does this interface have? Interface iterable. So first of all, it's parameterized. So this is just like a list. A list is parameterized with the items that it will maintain. So iterable is actually parameterized with the items that it will return. Right? So when you iterate through a list, what do you expect to get back? Well, for a list, you expect to get back exactly what the list contains. Right? So iterable supports a single method. It's a really simple interface. You can essentially just say iterator on this interface. So looking back at the code that I wrote here, when I wrote iterator sprite, iterator equals sprites.iterator, I was invoking exactly that method within the interface. Right? I can do this because sprites is a list, and a list extends iterable interface. And that iterable interface requires me to have this iterator method. And this iterator method returns an iterator. And that is the object that we're dealing with here. Right? So this is what I'm calling hasNextOn and what I'm calling nextOn. So an iterator interface requires just a couple of methods, really just 3. So it requires that I have a hasNext method, which will return true if my iteration has more elements. Note that this is really abstract. This is not talking about lists or sets. It's just talking about in the abstract. If you have some set of objects and you need to kind of traverse them, right? hasNext returns true if you have more things in the future. And then next will return the next element in the iteration. And remove is a way of also removing objects from this group of objects that you have underneath. So if I wanted to iterate over the sprites list and also remove all of the ones, or remove every second sprite, then I could call iterator.remove to make that happen. Okay, so one example of this pattern that we've already seen is actually in the alarm system project. So if you open up alarm system, there is a class called event log. And when you extracted the class diagram for event log, a lot of you notice that event log actually implements iterable. Implements this interface. So a lot of you had this question of what exactly is this thing? So now you can actually interpret it. So event log is a kind of object that you can iterate through. And when you iterate through an event log, what you get back are events. So if it implements this interface, it means that it must implement the iterator method, which is down below. So when I iterate through an event log, what am I actually doing? I'm iterating through the events that my event log contains. So this just returns the iterator for the events collection, which is defined at the top here. So what this code allows me to do is, if you look at tests for the event log, you'll see code like this. So in this code, I have a for each loop, and the for each loop is iterating through events in the event log. But what is an event log? An event log is a type that I added to the program. It's not a collection, it's not a set. It's a class that I defined. Right? And because I made it extend iterable, because I made it implement iterable, I can now write for each loops in this form, where it's really easy for me to express iteration over some type that I now introduce into my program.
So can you just explain what you have to do after you implement iterable? Then what do you have to do with the iterator method?
Well, all of that just means looking at the documentation, right? So if I implement an interface, what does that mean? What do I need to do? When I implement an interface, what is that? What is the requirement on the class? I have to implement all of the methods that are listed within the interface, right? So the interface has just one method. It's the iterator method. It takes no arguments, and it returns an iterator. So in the event log, it implements iterable event. So that method needs to return an iterator that goes through events. Right? So this is exactly the signature of my iterator method. And internally, all it does is it returns the iterator for the internal collection of events. So it doesn't create a new iterator, like a new fancy iterator. It just reuses an existing one. Right? But of course, you could create one. So you could create an iterator for objects that you care about and actually make, have them behave in a way that you want. So you can make sure that it has particular next behavior or has next behavior and so forth. So you could do that as well. And I think actually you're going to work on that in the lecture lab. Any other questions about iteration? So let's look at how this thing looks visually. So this is kind of what the iterator pattern looks like in code. Right? I have the for each statement. I have the desugared version, which allows me to kind of reap the full power of the iterator. So in practice, we like to write little class diagrams for our design patterns. So we can try to do the same thing for the iterator, except that it has a slightly strange diagram. So iterable is going to be an interface. And this interface has a single method, which is the iterator method. which returns a new iterator. Now, to give you an example of how it's used within collections, collections actually extends this interface. So collection is an interface. And it finds a bunch more things on top of this interface. And then, of course, down below you have more interfaces, more familiar interfaces like list, and set. And then these are subclassed with the concrete versions of these, right? So array list is down here, and hash set is on the right side. So this is what my hierarchy looks like for my collection classes. Now this iterator actually returns an object which is an iterator. So there's a class called iterator, iterator E. It's not a class, it's an interface. And this interface requires me to implement a couple of methods. So one of them is hasNext. One of them is next. And the last one is remove. So if I want an iterator of a particular sort, right, I'm going to actually create my array list iterator or my hash set iterator. Down below. So these guys are going to implement this interface. So the key thing to note here is that there's actually no linkage between iterable and iterator. Right? So iterable will return the right kind of iterator when you call its iterator method. But explicitly in the class hierarchy, there's no direct linkage between them. Right? So this is really what the pattern looks like. It's a little bit more amorphous, right? Because there's no direct connection between these interfaces. So just to give you one more example in code, we can look at the photo manager application. So in the photo manager, I'm going to want to, this is within the photo album base project. So photo album base, I have the photo manager. So if I wanted to write code which iterated over albums of my photo manager, right, we're going to do something very similar as in the case of the event log. Basically, I want to write code that looks like album A, photo manager, assuming that I have some kind of photo manager defined. So if I want to write code like this, a.print pictures, then we want an iterator over albums. So to be able to write this code, I need to make sure that my photo manager will implement my iterable interface. Now that it implements this interface, I need to fill in the one method, which is the iterator. And since I want this iterator to iterate over albums, I can simply do, as we did in event log, return an iterator for my internal set of albums. Right, so here, I can just say return albums.iterator. And so simply by adding this bit of code to my photo manager, I make it possible for me to actually iterate through albums within the photo manager. So if I didn't have this design pattern, it would be fairly difficult to actually do this, right? Because I would need to either expose my set of albums. Right now it's private. So I would need to make it public, perhaps, if I wanted to iterate over it. If I didn't want to make it public, then I would need some kind of method that would expose it to me. Maybe one at a time, right? So in a sense, I would need to implement this iterator within Photo Manager. So instead of doing that, I'm reusing functionality that's already within iterable and iterator, and I added just 4 lines of code to make it happen. Okay, so that's really the power of this iterator abstraction. Any questions? So we'll get to practice this now. So there's a lecture lab online, and we're also going to fill out TA evaluation forms. So the iterator abstraction is shown here, and then I have also pictures of TAs, some of the TAs shown here. So let me make them smaller. Can you guys still see that? Ah. So you should just go ahead and download the iterator lecture lab from the schedule. So I don't think I can make both of these fit simultaneously. Ah, now it's all gone. So I'll just blow this up instead. So we're going to do the lecture lab on Monday as well, so you can get a head start on it over the weekend. So in the meantime, let me get these out. So I need a volunteer to actually bring these back to the CS office, who's not a TA. They'll do it? All right. Thanks, Zach. Maybe you can hand these out on the side. I'll hand these out.
Before you do the TA thing, I'm just going to point out something important. There's 2 Brians. I'm Brian Tai with a Y. Brian Chow's the other one.
Oh yeah. I must note that, so the point of these is for you to evaluate TAs that you've actually come in contact with, right? So you don't need to fill this out for all of the people on the slide. So if there's a particular TA that, that you've interacted with, right, that you know about, that you recognize, then you should fill out one of these forms. But don't limit yourself to just one. So if there's a couple of people, then fill it out for a couple of people. Just make that a bunch.
Yeah, one for each team. You 3.
So you need one of these sheets for every TA that you want to evaluate. Okay, so if you need more sheets, I can give you more sheets. You do have to use pencil for this. I have a bunch of pencils. So if you need a pencil, please raise your hand and keep it up. And I'll come over with some pencils.
Course number of physics. What's happened is that it's almost shot up to
Pencils?
It'd be more entertaining to me. Yeah. Okay. I'm telling you, like a party for sure. No, it's gonna be fun. I want to be strong totally not because it's scary. I like don't even not try to hide.
If you fill these out, only pencils. There you go. Remember, only pencils, you guys, okay? Don't use ink. If you use ink, I can give you a pencil. And hold on to them, and then at the end of the class, you can bring them up to Zach over here in the front. I can also give you more forms if you fill them out with ink and want to redo it.
Or section lab second. Or the section number is that course or lab. Actually, couldn't afford a car in the lab. I just no, I don't. How do I get the bus number? To translate service. Because I get them to see this. I don't see We have a road number that's just the road number. Anybody that I want the bus. Buses don't have a name. Like just go. So it's just the road number. No, we'll even see it all. Well, go get 2 buses going one road. And 2 buses going on. Like sure, 2 buses. But do they have different same names? Like they're gonna both have like 49 or 19. Oh, so he gave answers.
figured it out perfectly because I thought oh, with the exact same too. But like it means that I can take my first year chemistry next semester.
He's like, nope.
If you filled out the forms, then you can start passing them over to, let's say, the center aisle. Okay, and then Zach will go around and actually collect all of them.
How do I get
That would be so well. Really? Did you get the message? No, I got it. I'm trying to figure out. I didn't notice that that was. I said it right now. It's so shit. I'm trying to figure out. I always feel like I should. What never said. Like you have to send something to that. I don't know what said the dialogue. In my is a description to the split. Yeah, I don't know if it's a description to the split or it'll be like. I think it's probably cool ways to do it. You can do like root to string, and then take root to string. But I have the string that I wanted to display. I just don't know how to actually display it. It's normally it'll be like on here when you put yeah, but I mean like it'll be like dialogue. Yeah, like if I click here, and it should show up there. Yeah, that's like dialogue. Ignoring the fact that it passes, it basically does the math and forth. So, although actually it's like straight up, it's one, going back and forth. I was just saying like take it to that. Whatever you call it. I don't think that's right. No, yeah. No, that's
I wonder if anybody's watching.
give you guys, which is already kind of what I'm not talking
What goes around comes around.
Yeah. Guy. So it's not you, it's the guy. Oh, okay, well.
So I'm telling you, get the fuck over it.
This guy's like fucking kid and shit. He fails. Oh, that's cool.
I'm working because I think you're close to mine. When I
Make my calculation. For me, they were. I usually don't. Not even for like 2 days, maybe.
so I'll just work on 8.
I have like sleep issues when I sleep.
8 doesn't.
I sweat a lot, and then I have like sweat, like vivid dreams. So I wake up from my dreams. And like my appetite is gone.
Unfortunately, the one guy who should be in there, I can't.
So did you guys look at, so you know that when you call get Waldos, it returns them in a random order. Yeah. Right, so you shouldn't be relying on get Waldos to return them in the same order each time. Right, I wonder if that might be something up. That might be the case.
I mean, it only works in one spot.
Yeah, like it works in ones that are moving. Right, because those are always at the bottom. So those are always going to be ordered. So the Waldos
Remember what emailed you? Because I need to find out what